In lesson 29, we cover things called quadrantal angles, and we have the tiniest of introductions to something called the unit circle. First thing we need to do is to define quadrantal angles. Those will be angles that lie on the positive or negative x and y axes. So 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, 450 degrees, and so on. Or we could also go in the negative direction with any of those. So what that would look like in terms of measures, we would have 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, or if we went in the negative direction, negative 90 degrees, negative 180 degrees, negative 270 degrees, and so on. The unit circle is going to be a special circle, and what makes it a unit circle is the radius must be 1. Now, if that happens, then the radius is 1, so this hypotenuse for any angle theta that I might want to draw would have to be 1. We know that the coordinates of this point right here would have to be xy just because of what we know about the coordinate plane. That's how far we go in the x direction, and that's how far we go in the y direction. Now, something special is going to start happening here. We know that by definition, the sine of theta is going to be the opposite over the hypotenuse. So in this case, the opposite is y, the hypotenuse is 1, so the sine of any angle theta, if the radius is 1, if it's on a unit circle, the sine of that angle will just be the y coordinate of that point where the line intersects the circle. Also, by definition, the cosine of theta has to be the adjacent over the hypotenuse, and if that radius is 1, then the hypotenuse is 1, and the adjacent side has to be x, so that means that no matter where we go on the unit circle, the x coordinate of the point where the line for the angle intersects the circle will also be the cosine of that angle as long as it's a unit circle and the radius is 1. Now, tangent gets a little bit more interesting because the tangent is going to be opposite over adjacent. So that is going to be opposite is y over adjacent is x, as long as we're on the unit circle. But we just saw that y is also the sine of theta. And we saw that x is also the cosine of theta. So that is going to give us a new formula that you may add to your formula list, that the tangent of theta can also be written as the sine of theta over the cosine of theta, and sometimes that is going to help us out a lot to be able to do that. So do get this copied down in your notes, in that list of formulas that you are keeping, that the tangent of theta is the sine of theta over the cosine of theta. And now we're going to use these things that we just figured out, that the cosine of an angle is just the x coordinate, the sine of an angle is the y coordinate, and this one over here, that the tangent is the y over the x as long as we are on the unit circle. And we are going to figure out things we haven't been able to do before. What is the cosine of 0? So we don't really have a triangle. Or the cosine of 90 degrees, so we don't really have a triangle. So if we are on the unit circle, which means r is 1. That means this point must be 1, 0. This one is 0, 1. This one is negative 1, 0. And this one is 0, negative 1. So if we want to get the cosine of 0 degrees, we are right here at this point marked on the circle. Those coordinates are 1, 0. Cosine must be the x coordinate, so cosine must be 1. Sine must be the y coordinate, so it must be 0. And tangent must be y over x, so it's going to be 0 over 1, which is also 0. And even though we don't have a triangle, if we try to draw something with the positive x-axis and 0 degrees, we just have that line segment. We have just defined those 3 trig values for 0 degrees. Moving next to 90 degrees, now we know we're at the top of the unit circle, so that point has coordinate 0, 1. Cosine must be the x coordinate, so cosine of 90 degrees must be 0. Sine must be the y coordinate, so sine of 90 degrees must be 1. Now tangent's going to get interesting, because tangent has to also be y over x, so that's going to be 1 over 0, but we can't divide by 0, so the tangent of 90 degrees is going to be undefined. It's not possible to get the tangent of 90 degrees. Next, we move to 180 degrees. So now we are at the point negative 1, 0. Cosine must be the x coordinate. Sine must be the y coordinate. Tangent must be y over x, so that would be 0 over negative 1, which reduces to 0. So now we know what the trig values are for 180 degrees. If we move to the bottom of the unit circle, now we can talk about the values for 270 degrees. That means we are at the bottom of the unit circle, so we are at 0, negative 1. So that means that the cosine of 270 must be the x coordinate, so it must be 0. The sine of 270 must be the y coordinate, so it must be negative 1. The tangent must be y over x, so it's now negative 1 over 0, but that does not work. We cannot divide by 0, so the tangent of 270 degrees is really undefined. And that would also be true if this was the cosine of negative 90 degrees, since that would be the same place on that unit circle. So now we have ways of finding trig values for 30s, 45s, and 90s because we know how to draw those special right triangles. And we know what happens when we are not just in the first quadrant, but in the second, third, or fourth quadrant, as long as we figure out the reference angle. We know what these are, and we can get their values without ever needing to use a calculator. Couple problems that I want us to practice together. Let's do this example. Here we have one that we want to evaluate, and we're going to use a combination of methods to evaluate this particular problem. 30 degrees, okay, I know where that is, so I'm going to draw my picture. That's first quadrant, and 30 degrees is about here. And you may do this one either of 2 ways. You may label it the way that you always have with a reference triangle, that the short leg is 1 and the long leg is 2. Or I'm sorry, the hypotenuse is 2 and the long leg is the square root of 3. Or you may do it as if it were on a unit circle, so that this is 1, and then that means that the short leg has to be half of the hypotenuse, and the long leg must be the short leg times the square root of 3, so root 3 over 2. Then when we want to get the sine of 30 degrees, we can either say opposite over hypotenuse from the top one is 1 over 2, or we can say from the bottom one, opposite over hypotenuse is a half over 1, which reduces to a half. Or we can say that the sine is simply the y-coordinate, which is positive 1/2, since we are in the first quadrant. For 270 degrees, that is going to be when we are at the bottom of the unit circle. So for this one, we simply want to say that the sine is the y-coordinate. If we are at the bottom of that unit circle, that means we are at 0, -1. So our y-coordinate is -1. For 90 degrees, we're going to be up at the top of the unit circle. And if it is a unit circle, then those coordinates are 0, +1. And this time we're looking for cosine, so we're looking at the x-coordinate, which is 0. And finally, for 330 degrees, we're going to be in the fourth quadrant. We know that the sine has to be negative if we are in the fourth quadrant. All students take calculus, so cosine would be the only positive one. We also know by looking at it that the x-coordinate would be positive and the y-coordinate would be negative. Again, just like we did with sine of 30, you may either label that picture by the way you have in the past, with 1 for the short leg, the hypotenuse is twice as long, and the long leg is the square root of 3. Or you may do it as if it is on the unit circle. So in this case, our radius or our hypotenuse is 1. The short leg has to be half of the hypotenuse, so a half. The long leg has to be the square root of 3 times the short leg, so the square root of 3 over 2. Then when we take the sine, we can do that as opposite over hypotenuse. So negative, because we know that we are in the fourth quadrant, negative opposite over hypotenuse a half, or this would really be the coordinates, positive root 3 over 2, comma, negative a half. And we know now that the sine, if it's on a unit circle, so the radius is 1, the sine is the same thing as the y-coordinate. So again, we would have negative a half. Final step would be to simplify this whole thing. The 1/2 and the -1/2 would cancel, leaving us with -1 as the answer for that problem. And then my final example today is just reviewing one that I know has been giving some of you some trouble, some of these abstract rate problems. So we are going to set this up with distance, rate, and time all in a table. And we're going to have the first time around, and let's see, the first time around, George drives H, so that's our distance. Speed is y miles per hour, so that is our first rate. And let's see here, if distance equals rate times time, that means time has to be distance divided by r. So just working off of that column, if d is h and r is y, that means my time has to be h over y. But that trip did not work out so great. So we need to do a new situation. George got there late. Now we want George to get there on time. The distance isn't going to change. George still needs to go h miles. But we're going to need to change the rate. We don't know to what, so I'm just going to say that that's going to be the new rate, so r sub n. And I need to get there faster. I took 4 hours too many the first time around. So this time, I need to take the time that I had before, that h over y, but I need to subtract 4 from it. Now, a trick to these is make sure you get a common denominator before you go any further. So let's multiply by y over y so that this new time is really h minus 4y all over y. Now, to get our new rate, if distance still equals rate times time, but now I'm talking about the new rate, my new distance is the same as the old. I don't know my new rate, and my new time is h minus 4y over y. If I want to isolate my new rate, I need to get just the r sub n, so I need to get rid of h minus 4y over y, so I will multiply by the reciprocal of that, y over h minus 4y. That means when I multiply the right side, I have only my new rate, which is what I want, because the y's cancel and the h minus 4y's cancel. On the left, though, I have h times y in the numerator and h minus 4y in the denominator, and that will be my new rate. All I need to do is look back at the problem so that I can label my units in this one, and my units for rate are miles per hour, so I label that as miles per hour and circle my answer. And hopefully that gave you another example to help clear up some of the confusion that some of you have had on these problems so far. And it lets you understand those quadrantal angles and how we can evaluate sine, cosine, and tangent, even when our angles lie on one of the axes.